Today we will see about Unit 3 in mobile computing. I'm Amritavalli. Today we are going to see about wireless telecommunication systems, where you will see GSM and UMTS. Okay, we'll go into the chapter now. So this is the development of mobile telecommunication systems. It was AMPS, NMT first. From there, that was called as 1G, and from there, GSM actually. We have other technologies like TDMA, DMS, PDC, but GSM was the one which was very popular, and also CDMA 1 was very popular. Okay, so this is 2G. In 2.5G, we have GPRS and EDGE. Again, in CDMA 1, that was advanced to CDMA 2000. Okay, later we had 3G, where Ultra FDD WCDMA was used widely. And then nowadays phones, that is 4G is available. Also, we have 5G, which is currently developing. Okay. So we'll see about GSM in detail. It was called as formerly called as Group Special Mobile in 1982. Now it is called as Global System for Mobile Communication, and it was ETSI, that is a pan-European standard. Okay, and it was introduced simultaneously in various European telecommunication administrations, like in Germany. Okay, but it is now it was available in Asia, Africa, Europe, Australia, and America. And you can see that 4.2 billion subscribers in more than 700 networks were being used by this GSM, and 75% of them all had digital mobile phones. In Germany alone, they had 29 million SMS. Okay. So about performance characteristics, it provides communication, it provides total mobility, worldwide connectivity, high capacity, high transmission quality, and security functions like access control or authentication through chip card and PIN. Okay, disadvantages was it was not a perfect system because there was no security at all, and reduced concentration while driving. There were chances of handoffs. Electromagnetic radiation was present. Private data was still it was easy to capture. Roaming profiles were accessible. Okay, and the system itself was very complicated, along with several incompatibilities with the GSM standards. So what are the kinds of mobile services it offers is, there are three basic services: bearer services, telematic services, and supplementary services. You can see in the diagram, the bearer services is from the terminal equipment to another terminal equipment. Okay, teleservices also. And how is it? You can see the model of this. Between the terminal equipments, you have a mobile terminal, and they are connected by GSM PLMN, and you have a transit network which can be your PSTN or ISDN, and there'll be a source destination network. We'll see about these services in detail. Okay, you can see this bearer services. Bearer services are not nothing but the services. It talks about the physical layer, how and how is error correction, etc. is done. Okay. So what will be the data rate for the voice and for the data, and what are the kind of service it provides? Okay, it provides two kinds of services. One is transparent bearer service. Another one is non-transparent bearer service. Transparent bearer service, it takes care of forward error correction, and it is generally it is circuit switched, and it has a constant delay and throughput. Whereas in a non-bearer service, non-transparent bearer service, you can see it is used in layer 2 and layer 3, and for the sake of error correction and flow control. And it is packet switched rather than circuit switched. And approximately 50 kbps data rates are possible. In telematic services or teleservices, you can see the services that are offered are mobile telephony, which we usually talk. I mean, whenever we call, this is a service that has been used up. Okay, and they have the emergency number, like SOS number. Okay, and multi numbering, where several ISDN phone numbers per user is possible. Other services are non-voice teleservice, like group 3 fax, voice mailbox, electronic mail, and SMS. SMS, this was short message service, which is which you can actually, I mean, you can send only 160 characters using this, and it was widely used during 2G. Now we'll see about supplementary services like identification, like who is the caller, suppression of number forwarding, automatic callback, conference call, and locking of the mobile terminal. Okay, incoming and outgoing. I mean, you can do this. We'll see about the architecture. Okay, the main components are, I mean, GSM is a PLMN, that is nothing but public LAN mobile network. Okay, and the components are mobile station, base station, mobile switching center, location register, radio subsystem, network and switching subsystem, operation subsystem. Okay, so other, I mean, other entities are, I mean, within the radio subsystem, the whole of the architecture can be divided into 3: radio subsystem, network switching subsystem, and operation subsystem. In radio subsystem, we have mobile station. Within mobile station, it has 2 entities, mobile equipment and SIM. Whereas in base station subsystem, we have BTS, that is base transceiver system, base station controller. Similarly, in network switching subsystem, we have a mobile switching center, home location register, visitor location register. Then we have operation subsystem, which is operation and maintenance center, authentication center, and equipment identity register. Okay, so what is visible in this network is very small. Only these equipments you can see. Okay, but what is actually still visible? These are some of the things that are still visible, like these antennas and some infrastructure like base stations, cabling, microwaves, links, etc. But what is not visible is your switching units, management, databases, monitoring. All this is not, I mean, these are transparent to the user. Okay, so this is the basic architecture of GSM. You can see there is a, you can see clear, subsystem, all the 3 subsystems, like radio subsystem, network and switching subsystem, and operation subsystem. Okay. So this is another way of expressing your same GSM. And you can see in RSS, that is radio subsystem, you have BSS. Okay, and within one BSS, we have n number of cells called radio cells. Each of the radio cell contains, consists of 1 BTS. Okay, so this BTS is nothing but your antenna, okay, which is connected to your mobile stations. Okay, through the interface called UM. Okay, so through this interface, this is air interface between your mobile station and your BTS. Okay, so whenever there is a call, incoming call or outgoing call, all this is carried by this through this interface UM. Okay, now within each cell we have already, I have already told that we have BTS. Each of the BTS is connected to BSC. For each BSS, we have only one BSC, base station controller. Okay, so this base station controller, along with so many BSS form your RSS, that is your radio subsystem. Okay, so how is this BTS and BSC communicate is through this ABIS. Okay, BSC, all the BSCs are actually connected to MSC. MSC is part of your NSS. Okay, so this MSC and BSC is connected via A interface. Okay, and your MSCs and other MSCs are actually connected directly. Each MSC consists of 2 databases. One is VLR and HLR. Okay. VLR is visitor location register and HLR is home location register. And some of the MSCs are connected to GMSC, which is gateway MSC. Okay, and it is actually connected with the IWF. Okay, this is about NSS. So your GMSC and your MSC is connected with OSS, to OMC, Operations Maintenance Center, via O interface. Okay, apart from OMC, we also have AUC, Authentication Center, which is connected to HLR. And we also have EIR, which is Equipment and Identity Register. Again, that's a database. So we have totally 3 databases in overall in your GSM. One is VLR, HLR, and EIR. EIR belongs to OSS. Okay. So this is how it is connected, system architecture. You can see all the interfaces here, which I have already talked about. MS and BTS is connected via UM. BTS and BSC is connected via ABIS. BSC and MSC is connected via A interface. And within radio subsystems, we have n number of BSS. Okay. And within network and switching subsystem NSS, we have MSC and GMSC is also present. And it is connected to the databases EIR, HLR, and VLR via SS7, signaling standard 7. Okay. And these are again connected to ISDN and PSTN. Okay. So we have talked about this also again in detail. You can see the diagram. Okay, so I've just given a general overview of how things happen. Now we'll see about each of the subsystem in detail. Okay, so one RSS comprises of cellular mobile network up to the switching center. Okay, that is it is connected to the MSC. That is what they are telling about. BSC. Okay, the components of your RSS are mobile stations. Mobile stations are nothing but your actual equipments, your mobile phones. So these are connected to BSS. Within BSS we have MS, BTS, and BSC. Okay, and your MS is connected to your BTS. BTS is nothing but a base transceiver station. The word transceiver itself tells that it transmits as well as receives. Okay, so data to the MS or from the MS. Okay, so the BTS consists of everything that is required for this data transmission, like antenna. Okay, so next we have a base station controller, which is nothing but switching. It switches between BTSs, because a number of BSCs will be connected with the one BTS. Okay, and this is the one which controls all the other. BSC controls the BTSs and also manages the network resources and mapping of radio channels. Okay, so BSS is nothing but a combination of BSC, BTS, and the interconnection between them. Is about the mobile equipment. Mobile station consists of 2 things: mobile equipment and subscriber identity mobile, which is nothing but the SIM. So you can see there are 2 different entities: your actual mobile phone and the SIM card, where we store all the relevant information. It actually contains several temporary and some permanent data regarding the subscriber, mobile, and the network. So some of the information that is carried by SIM is IMSI number, which is International Mobile Subscriber Identity. Now, second one is MSISDN of